A very good morning to all. I am Mr. S. S. Sazne, Assistant Professor working at Department of Mechatronics Engineering, Sharad Institute of Technology, College of Engineering. Today we are going to discuss on the topic temperature measurement. So in this part we are going to see different instruments that we can use to measure the different range of temperature. So what will be the outcome of this part is given here. The students will be able to explain electrical and non-electrical methods of temperature measurements, uh, use high temperature measuring instruments such as pyrometers. So I think that up till now you have just heard regarding thermocouple or thermistor, then again liquid in glass thermometer. So but practically you have only used liquid in glass thermometer to measure the temperature, right? So what you are going, I am expecting that after going through this part, that is the temperature measurement, you should be able to know that what are the different instruments that you can use according to the application, that is for different applications where the temperature is very high. So at such situations which instruments you have to use to measure the temperature, so that you should understand from this part. Okay, so as given here, we are going to study the electrical and non-electrical methods of temperature measurement. Okay, so in the next slide, we will see how to measure the temperature. Just a minute. Okay. So first, we will try to understand what is the temperature. So here they have given the temperature is an intensive property. Okay, now, what is the meaning of intensive property? So, intensive property is the property which does not depend on mass of the system. Okay, so temperature does not depend on mass of the system. Uh, if we if we want to define what is the meaning of temperature, then we can define the temperature as the degree of hotness or coldness. So there are many applications where you can feel during summer season at afternoon session you can feel the hotness. Okay, so since the temperature or the sun rays reaching the atmosphere is of high intensity, so you are feeling very hot. But if you look in at the morning session, if you consider, then at that time the temperature is very low. So you are feeling this intensity of hotness or coldness. So we are relating this degree of hotness or coldness with temperature. So with the value of temperature, we can define that this object is either hot or cold. Okay, so temperature we simply define it as the degree of hotness or coldness of an object. Then the next term is thermal equilibrium. I think that you have also studied this thermal equilibrium. Then again, there were two more terms with this thermal equilibrium. I think that was a mechanical equilibrium and chemical equilibrium. So in simple words, I have told you what is the meaning of thermal equilibrium. If the temperature of the system at any point, if you are measuring the temperature at any point, and if that temperature is same, then we call it as thermal equilibrium. Okay, in simple words, thermal equilibrium means the condition of the body which determines the transfer of heat to or from other bodies. This is the one definition. And the other one is, I have already told you or you have already studied, that if the temperature uh, at any point of the system is same, then we call it as thermal equilibrium, or the system we call it as it is in thermal equilibrium. Then the next point is effects due to temperature. Okay, so what are the effects due to temperature that are given here? First is change in phase or physical state. If you consider ice, you have also studied how the formation of steam take place. Okay, so first we have considered ice. Then when we are adding heat to that system or to ice, then it is converted into liquid. Again, if you are adding heat, then it is converted into gaseous state. Okay, that is steam. So due to the temperature, as the temperature goes on rising, what is happening? there is change in the phase of that system. Okay, that means ice is converted into liquid and then liquid is converted into gas. So with this change, there is also change in dimension. Okay, the dimension of the ice, if you consider as a cube, then when it converts into liquid, again its dimension changes. When it again converts into gas, again its dimension changes. So due to temperature, there is also change in the dimension. Then there also can be change in the electrical properties. Then again, the next point that given, that is Seebeck effect. We are going to study the Seebeck effect later. Then the bimetallic strip application, that is also a type of temperature measurement which we are going to study soon. And radiation, it is the mode of heat transfer. Okay, so in thermal engineering, the last part or the last chapter that you have studied, that is important at this point for the temperature measurement. This chapter, you can relate many points with the last chapter of thermal engineering. So you might have studied that there are three modes of heat transfer. One is the conduction, second is convection, and the third one is radiation. Okay, so by these three modes, heat is transferring. Okay, so we will try to recollect all those points that you have studied in thermal engineering while studying this temperature measurement part. So next point is the temperature scale. So you should know how to convert the degree Celsius into degree Fahrenheit. So that we are going to study in this part. Okay. So basically you have to remember these three scales of temperature measurement. That is, first one is the degree Celsius, second is Fahrenheit scale, and the third one is degree Kelvin scale. For if we talk about centigrade scale, then we know that the freezing point. Okay, the freezing point is 0 degree Celsius. We call it as ice point, which means that the temperature at which water is converted into solid state, that is 0 degree Celsius. Then steam point is 100 degree Celsius. Okay, so what does this mean? It is the temperature, that is 100 degree Celsius is the temperature at which water is converted into gaseous state. So let us just tell you that this temperature scale has been designed with keeping the reference as a water. We know that water is naturally available on the earth in all the three forms or all the three phases. That is, you can see the water in gaseous state in the form of steam. You can see water in the form of liquid, and you can also see water in the form of ice in most of the parts of the country. Okay, so water is the only element which is available naturally in all the three forms. So we are considering the water as a reference, and using this reference we have designed one scale, and that scale is referred by everyone nowadays. So they have considered the water as reference. What they have done while designing the scale, that is, right now we are saying this is 10 degree, this is 20 degree, the atmospheric temperature is 33 degrees Celsius. So how you are telling this temperature? There is one reference that is used to measure this temperature. So how this reference has been designed? That is designed with the help of water. What they have done, they have carried out an experiment. They take water and they start reducing the temperature of the water. Okay, so after certain time, what they found that after some time they identified that the liquid has been converted into ice at a particular temperature. So they marked that temperature as 0 degree Celsius, which we now call it as freezing point. Okay, then again what they do, they started adding heat to that water, as a result of which the temperature of the water start rising, and at a certain point they found out that the water is converted into steam. So at that point where the water is converted into steam, they mark that point as boiling point. See, and what these two markings, that is freezing point and boiling point, they divided this region into 100 equal parts. Okay, and that one part is contributing now as 1 degree Celsius. Okay, so I think that right now you have understood how the scale has been designed, that is 0 degree Celsius or 100 degree Celsius. Now let's see the next scale. Next is the Fahrenheit scale. So for Fahrenheit scale, the ice point is 32 degree Fahrenheit and the boiling point is 212 degree Fahrenheit. So the internal division that is not required. Just remember the same how the centigrade scale was designed. That is the freezing point and boiling point of water was taken as a reference, and those references were divided into 100 equal parts, and that one part is contributing now as 1 degree Celsius. Then after Fahrenheit scale, the next scale is Kelvin scale, where the freezing point is 273 Kelvin and the boiling temperature is 373 Kelvin. Later we will see how to convert centigrade to Fahrenheit or to Kelvin. Okay, so we will see. I will give you formula for this conversion. Here you can see how to convert degree Celsius to Fahrenheit or degree Celsius to Kelvin. So in this slide, here you can see when we want to convert the given temperature into Fahrenheit, degree Celsius into degree Fahrenheit, then what formula you have to use is given here. So you have to just multiply, just a minute. Say for example, if I give you a temperature in degree Celsius as 10 degrees Celsius, and if I ask you to convert this 10 degree Celsius into 10 degree Fahrenheit, then what you have to do, you have to just multiply that 10 with 1.8 and you have to add 32 into that value. So whatever the answer is coming, that is nothing but the temperature in degree Fahrenheit. Okay, so this is the simple formula. Whatever the temperature is given in degree Celsius, you have to multiply that given value by 1.8 and add 32 into that value. Okay, so the upcoming or the resultant value will be in degree Fahrenheit. Now, if you want to convert degree Celsius into Kelvin, then this formula is very easy. Whatever the value is given in degree Celsius, you have to just add 273 to that value. So the output will be the temperature in Kelvin. Okay, so just remember this formula for the conversion of temperature from degree Celsius to Fahrenheit or degree Celsius to Kelvin. If they have given the temperature in Kelvin and if you want to convert that into degree Celsius, then simply you can subtract the value and you can get the temperature in degree Celsius. Okay, so just remember, for converting degree Celsius into Fahrenheit, multiply by 1.8 to that temperature and add 32 to that value. And when we are converting degree Celsius to Kelvin, just add 273 to that value. You will be getting the degree Celsius temperature into Kelvin. Okay, so this is the temperature scale conversion. Now we will see what are the temperature measurement methods. So first is the change in physical dimensions. So by using this concept, that is by changing the physical dimension, how to measure the temperature, that for that we are having two instruments which we are going to study in detail in the later slides. First is liquid in glass thermometer. I think that all of you have used this instrument, that is thermometer, to measure the temperature. Still we are going to study that. The next one is bimetallic element. So how the physical dimensions changes, and with the help of that how we are going to measure the temperature, we are going to study that in this part. Then next we are going to see the change in gas pressure or vapor pressure. Then by changing the gas pressure, how to measure the temperature, we are going to study that. In that we are having these types, that is constant volume gas thermometer and pressure thermometer. After that we are having the next type as changes in electrical properties. Okay, so here we will be requiring external power supply to measure the temperature. So in that we are having resistance thermometer, then again thermocouple, thermistor, all these types we have to see. Then after that we are going to study the changes in emitted thermal radiation. That is optical pyrometer and radiation pyrometer are the two devices that we are going to study under this point. So these optical pyrometer and radiation pyrometer, these are the devices which are used to measure the temperature, which are having very high range. That is, if the temperature is above 2000 degrees Celsius, at such applications, it is necessary to use these devices, that is a radiation pyrometer and optical pyrometer. So if we are measuring the temperature which is below 2000 degrees Celsius, then in those applications we can use these upper 3 points. Okay, so we can use thermistors for measuring the temperatures ranging from 400 degrees Celsius to 1500 degrees Celsius. Or we can use thermocouples in the range 200 to 400 degrees Celsius. Okay, if we are having temperature less than 100 degrees Celsius, then already you are using liquid in glass thermometer. For temperature which are exceeding 100 degrees Celsius to say 250 degrees Celsius, we can use bimetallic element. So there are different, based on the application or what is the actual temperature, based on that temperature we can select what instruments that is appropriate for measuring that temperature. Okay, so all these instruments we are going to study under this part.